Hello everyone, I'm Poonam Sharma, your science teacher. Welcome you all another session of chapter Structure of the Atom. In previous class students, we have discussed about various models proposed by different scientists for the structure of atom. How atom looks like, what are the subatomic particles present in them and how they are located, or what kind of charge present on an atom. So these points we have already discussed in previous class, where I have discussed about Rutherford model of an atom, J.J. Thomson model, which are very important models, extremely important according to exam point of view. So I hope you have revised those topics and have gone through each and every detail. Now in today's class, I'll explain one more model of the structure of atom, which was given by Bohr. Now in previous class, we have discussed these points. Till here we have covered so far. So now in today's class, I'll discuss Bohr model of an atom. Neil Bohr, he is a renowned scientist. He gave his model of an atom on the basis of observations of the Rutherford, and which were not explained by Rutherford in his postulate. He explained and he cleared those points. There were some drawbacks in Rutherford model also. But if we are talking about Bohr's model, he cleared those doubts, and that's why Bohr's model is the most acceptable model related to the structure of atom. So if we are talking about the structure of atom, we always consider the most adaptable and the most suitable model is a Bohr's model. And the full name of Bohr is Neil Bohr. In his model, he said that although atom is a sphere in which electrons are revolving in a particular orbit, and inside the nucleus, neutron and protons are present. So inside that nucleus, which was discovered by Rutherford. So Rutherford discovered nucleus. And in Bohr model, he said that in the center of the atom, nucleus is present and the electrons are revolving. But when they are revolving in a particular orbit, which we call energy shells. So when these electrons are revolving, here I'll draw the structure of atom according to Bohr model. This is the structure of atom. It is sphere in structure, and nucleus is present in the center, on which positive charge is present due to the presence of protons, and the electrons are revolving around it in a particular energy shells. So these are the energy shells which are present inside the nucleus, in which electrons are revolving or rotating, and these are known as energy shells or energy levels. So when these electrons are revolving, they'll not release or they'll not radiate any kind of energy. This point explains the stability of the atom. So when these electrons are revolving, they'll not radiate any kind of energy. So that's the reason why electrons does not go inside the nucleus. So they keep on revolving around the nucleus. So these were the postulates given by Neil Bohr. And he said when these electrons are revolving in an energy shell, they are not radiating any energy. But if these electrons are jumping from one energy shell to another energy shell, so they'll emit or absorb energy. So if the energy which is represented by E, so there's a change in the energy which is represented by En2 minus En1. So energy of higher shell minus energy of lower shell. So to be stable in nature, they jump from one shell to another shell. So when they are jumping from one shell to another shell, then they are either absorbing or emitting energy. So, and in this state, they are said to be in a excited state. So when electrons, these are electrons, so this is one energy shell and this is two energy shell. So if the electrons are jumping from lower to higher energy level, so in this state it is known as excited state, and in this state it absorbs the energy. So, and second one is if electrons, these are the electrons which are rotating or revolving in the orbits. So when they jump from higher to lower, it means En2 to En1. So they are emitting energy. So in this state, the atom is not stable. When they are jumping from one energy shell to another, only in this state they are not stable. So either they are emitting energy or absorbing energy. And this energy, this change in energy is represented by this symbol. This is known as change in energy, because energy is changing when the electrons are jumping from one energy shell to another. Only in this state they are not stable. And once they move, then they become stable in nature. So this is given by Niels Bohr, that there is a change in the energy when the electrons are jumping from one to another energy shell, either from lower to higher or from higher to lower. And this was the structure of atom given by Bohr, that in the center nucleus is present which contains positive charge, and the electrons are revolving in these orbits. These are the electrons which are revolving in particular orbits and which he named energy shells or energy level. And these shells are represented by these alphabets K, L, M, N. So this was a model given by Bohr, and here N is equal to 1. So here N is equal to 2. So this is energy shell 1, energy shell 2, energy shell 3, energy shell 4, and here nucleus is present. So they keep on revolving and they are not radiating any energy, but these electrons can jump from one energy shell to another energy shell to be stable in nature. Now question can come, draw a sketch of Bohr's model or write the postulates of Bohr model. If the question comes, draw the sketch, then you have to draw this diagram in which you will show the position of nucleus, which contains positive charge, and the electrons are revolving around it in different energy shells, which are represented by K, L, M, N. Or we call them energy levels also. Now, how these three models are different from each other. If you look at these three models, which are very important to tell the structure of atom. So first is the Thomson model, and second is Rutherford, and third is Bohr model. So how these models are different from each other. Although all the models given the theory of the structure of atom, how this atom looks like, but they have given different theories. First, if we talk about Thomson model, so this is the comparison between these three models, which shows the structure of an atom. So first is Thomson model, who stated that in an atom, positively charged particles that is present on the entire space, and electrons are embedded in it. So according to Thomson, the entire atom is made up of positive charged sphere in which in the center, electrons are embedded into it. And he said that the negative and the positive charges in an atom are equal in magnitude. And that's why that entire atom is electrically neutral. So these were the points or the postulates given by Thomson in his model. And if we compare Rutherford model from Thomson model, he said that positive charge is present in the center, and that is known as nucleus. So Rutherford discovered nucleus. He discovered this term nucleus, which is present in the center. And it's a 1 mark question. Who discovered nucleus? And answer is Rutherford. Then second point in Rutherford model is near all the masses of an atom resides in the nucleus. As I told you, nucleus is the combination of neutrons and protons. So the entire mass of the atom resides or present in the nucleus. And third point, which is included in the Rutherford, is electrons revolve around the nucleus in well-defined orbits. So he said that electrons are revolving in the atom around the nucleus, and size of nucleus is very small as compared to the atom. Because if you remember, I explained the entire Rutherford model, alpha scattering experiment, in which he bombarded alpha particles on the gold foil, and then there were certain observations. Few were deflected back, few were passed in the straight direction, and few bounced back. So on the basis of those observations, these were the conclusions or the postulates given by Rutherford in his model. And if we talk about Bohr model, so he said that in these special orbits in which electrons are revolving, we call them energy shells. And when they are revolving in these discrete orbits or energy shell, these electrons do not radiate energy. So this point proves the stability of an atom, which was missing in Rutherford model. Although all these models are related to each other, but Bohr model is the most acceptable one because he cleared that point of the stability of the atom. And he said when these electrons are revolving, they will not radiate any kind of energy. Because if they radiate energy, they go inside the nucleus. So they are not radiating any energy when they are revolving in a particular orbit. Although atoms become unstable when they move from one energy shell to another energy shell. Now question can come that compare all the proposed models of an atom in this chapter. So in this question you need to write all these 3 points, or you compare these models in a tabular form. This is the best way to represent your answer. This gives the clarity of all the models in detail. So when this question can come in exam, generally it comes in 3 marks. So in that you'll explain all the postulates of all the 3 models given by Thomson, Rutherford and Bohr model. So this is extremely important table which gives the summary also of 3 models given by these 3 scientists. Now according to Bohr model, there is a distribution of electrons. How electrons are distributed in particular orbits. He has given that name energy shells to those orbits, and when the electrons are revolving in these energy shells or in orbits, so these electrons when they are moving, there is a fixed number of electrons are there. In each energy shell, fixed number of electrons can accommodate, and these energy shell, there is a formula to find out the maximum number of accommodation of electrons in a particular orbit or energy shell, and formula is 2n square, where n represents the shell number or the orbit number. Like if you look at this diagram here, these are the energy shells 1, 2, 3, 4. So these are represented by this n. So n is the energy shell or the shell number or the orbit number. So N1 represents K shell. I'll draw here. This is K shell, K, L, M, and this is N. So K shell, L shell, M shell, N shell, and this is nucleus. Okay. Now N represents the number of the shell. So N1 means K shell. So according to the formula, if we'll write 2 in place of N, because N shows a shell number, so I have written 1 here and 2 square. So if you'll solve it, it becomes 2 electrons. And if we are talking about n is equal to 2, this is L shell. Now write in the comment box number of electrons in all the shells. Solve it simultaneously. I'm also doing it. 2 into 2 square. Here again n represents the number of shell, or L is the second shell. So if you'll solve it, 2 multiplied by 4 is equal to 8. So it means in L shell, 8 electrons can accommodate. Then n is equal to 3. It is M shell. So 2 in place of n, I will write 3 here, and then if you'll solve it, it accommodates 18 electrons in it. So it means in M shell, 18 electrons can come, and n is equal to 4. This is N shell. So here it means we are talking about N shell, and 2 4 square is equal to 32 electrons. So now from this formula we can say that in K shell 2 electrons can come, in L shell 8 electrons can come, and in M shell 18 electrons can come, and in N shell 32 electrons can come. But to exist in nature or to be stable in nature, there are two possibilities for an atom. So what or an element. So what are those possibilities? That either it has outermost shell K which has 2 electrons, or if any other shell is the outermost valence shell, so it has 8 electrons in its outermost shell. So these are the two conditions for the stability of an atom in the nature. First is K should be the outermost shell, and it has 2 electrons. If any other like L, M, N shells is the outermost shell, so it should have 8 electrons. So these are the two conditions to be stable in nature. So this shows that how many electrons can accommodate in these energy shells. The maximum number of electrons that can be accommodated in the outermost orbit is 8. Okay. And electrons are not accommodated in a given shell unless the inner shells are completely filled. It means first we have to fill the previous shell. For example, we have K, L, M and N. So first we need to complete this shell, and once it is completely filled, then only we'll add electrons in the another shell. And once L can be completely filled, then only we'll jump to the another shell. Otherwise, we'll not add any electrons in the another shell. And once M is completely filled, then only we'll move on to the N shell. So these are the conditions for adding number of electrons in the energy shells. Now, there are certain questions which can come in exam, like atom of an element A has 3 electrons in its outermost shell. It loses one of these to the atom of another element. What will be the nature and value of charge on the ion which results from A? So these kind of questions are totally based on the electronic configuration of the atom. Now, how this electronic configuration can take place? So before discussing those questions, first I'll tell you how to form these electronic configuration. Now, first of all, if you look at the example, before that you should aware about a few terms, that is valency. The combining capacity of an atom is called its valency. Atomic number is an equal number of protons, and mass number equal to the sum of protons and neutrons. Although atomic number and mass number and valency I'll explain in detail later. So first you need to focus on this term, which is valency, combining capacity of an atom. Let's take some examples how to write electronic configuration of different elements. So this term, this valency term should be clear to you. First, I'll take an example of sodium element, and its atomic number is 11. So children, you need to learn atomic number from 1 to 20 at least. Then only you'll be able to write their electronic configuration. So you have to learn these atomic numbers by heart. Sodium atomic number is 11. So according to Bohr rule, K, L, M, N. These are the energy shells, and according to the rule, in K only 2 electrons can accommodate, and in the outermost 8 electrons can accommodate. So first 8, we'll write 8 and it is completely filled. Now let's move on to the another one. 8 and 2 is 10. If we'll add these, it becomes 10. But its atomic number is 11. So we'll need one more. So I'll write 1 here. So this is the electronic configuration of sodium. But here outermost shell is M and it has only 1 electron. So it means it is not stable in nature. And if any element wants stability in the nature, so it should have 2 electrons in the outermost shell, which is K, but here outermost shell is M, or it has 8 electrons in the outermost shell. So to make 8 electrons in the outermost shell, there are 2 conditions. And what are those 2 conditions? Either it will accept 7 electrons from the neighboring element which exists in nature, or it will lose 1 electron to be stable in nature. So we always consider here, now you can see electrons are jumping from one shell to another shell. So it is easy for an element to lose electron in this case, because it lose only 1 electron. If it gains 7 electrons, it is a difficult task because it needs tremendous amount of the energy. So for easier one, we always go for the easy task, and here it lose 1 electron. So if it lose 1 electron, it attain positive charge on it. Okay. So here, if an element loses electrons, it has positive charge. If it gains electron, it has negative charge. So here it is losing 1 electron. So this is known as its valency. As I said, the combining capacity. So here the combining capacity of this sodium is 1. So it means it is combining with one of its electron to the neighboring element. So this is known as combining capacity of the sodium, and its valency is +1 because it is losing 1 electron. So I hope this is clear to you. Another example is chlorine. Its atomic number is 17. And if I'll write its electronic configuration, again according to the rule, here only 2 electrons can accommodate. So first I'll fill L shell by 8 electrons. Now how many are left? Write in the comment box. 8 and 2 is 10. So it means 7 are left. So I'll write this 7 here. Again, its outermost shell is M and it has 7 electrons. So it means again it is not stable in nature. How it becomes stable? Any idea? Write in the comment box and tell me how this chlorine becomes stable in nature. Again there are 2 conditions. Either it loses 7 electrons or gain 1 electron. So we always go for the easy task. So here it will gain 1 electron. So if it gains 1 electron, so here it is accepting 1 electron and its valency becomes 1 negative. So this is the valency, this is the combining capacity of chlorine. So here it is accepting 1 electron from its neighboring element to be stable in nature. And that's the reason why this NaCl, which is known as common salt, or we call it table salt, it exists in nature, because here this Na, which is sodium, it combines with chlorine, because sodium wants to leave one electron and chlorine wants to accept one electron. So they become true friends here. They are true friends. One is giving and the other one is accepting. So if they are giving and accepting in this manner, they both become stable in nature. And this tendency of losing or accepting electron is known as their valencies. So I hope this is clear to you what is valency and what are valence electrons. So these are valence electrons. Outermost shell contain 1. Here it is 7. So if I'll say valence electron, in case of chlorine, it is 7. Because 7 electrons are present in the outermost shell. But if we are talking about its valency, it is 1 minus. Similarly, for sodium, valence electron is 1, because in outermost shell only 1 electron is there, and its valency is 1 plus. So when we are writing valence electrons, we'll not write charges here, but in valency we'll write, because it shows whether the element is accepting or gaining electrons, and that's the reason how they becomes cations and anions. So this sodium becomes cation because it is losing electron, and chlorine becomes anion. Now I think this concept is clear to you, how these elements become stable in nature, how they are losing or gaining electrons, how they become cations and anions in nature, and how they react with each other to be stable in nature. As a result of this reaction, they'll form compounds which exist in nature. This is how existence of compounds takes place in nature. So I hope this topic is clear to you. So you need to learn atomic number till 1 to 20. So I'm giving you one homework. Learn atomic numbers from 1 to 20. This is for one task. And second task is write the electronic configuration. Write electronic configuration of aluminium, magnesium and oxygen. So these are the 2 questions I'm giving you as a home task, and in next class I'll discuss these with you. I'll discuss valency and valence electrons of each and every element from 1 to 20. So first learn these atomic number and write down their electronic configuration. This is known as electronic configuration, which I have written, which represents the number of shells and the number of valence electrons and valency. So this representation is known as electronic configuration. So these are the 2 questions. If you know the answer, write in the comment box, and in next class I'll discuss more valence electrons and valency of elements which have different atomic number. So till then, goodbye and take care. Thank you everyone.